Hello students, welcome back. In this video lecture, we will discuss about full wave rectifier. Let me write a name as full wave rectifier. As in the first lecture, I told you that full wave rectifier has two types. One is full wave center tap rectifier, that let me write it as full wave center tap rectifier, and another type is bridge rectifier. Now first we will discuss about full wave center tap rectifier. We have half wave rectifier, and then we have started with analysis of half wave rectifier. We have finished the analysis and then we turn towards full wave rectifier. We have two types. One is full wave center tap rectifier, another one is full wave bridge rectifier. We will start with full wave center tap rectifier. We will understand the circuit diagram, its operation, its waveform, and then we will switch towards its analysis. When we finish with the analysis of full wave rectifier, then we move towards bridge rectifier. In bridge rectifier, again we will understand its circuit diagram, waveform, its operation, and then we will start with the analysis of bridge wave rectifier. Right? This is how we will continue with this rectifier study. Now let's start with the first type of full wave rectifier, that is full wave center tap rectifier. Now as its name is quite different, full wave center tap rectifier, it is because the transformer that has been used here, this transformer I am talking about, this transformer, the type or a name of that kind of transformer is center tap transformer. Right? So center tap transformer is used in this circuit, and that's why this circuit is called center tap full wave transformer. Sorry, rectifier. Is it? So got the reason? The type of transformer is center tap, and that transformer we are using in this rectifier. That's why it is full wave center tap rectifier itself. Now let us discuss something about this center tap transformer. Look at this. It is a center tap kind of configuration. We have one full primary. Look at this. We have full primary, but at the secondary we have one common terminal. Is it? I will call it as common. Is it? One common terminal, and because of that common terminal, the secondary is divided into two parts. If I call it as part 1, and this must be a part 2. So secondary of the transformer is divided into two parts. Is it? And this dividation is called center tapping. One tap we are taking as a common, and we divide the secondary into two parts. Is it? So that is what center tapping. Is it? That is what center tap transformer is. So it means now in this transformer I have one primary. Now look at this, one primary and two secondaries. One primary and two secondaries. This is the actual configuration of center tap transformer. Now the operation of the rectifier is well known to us. Is it? We have a background of first year engineering. So operation is known. The only important thing is to understand that I'm using center tap transformer. It means I'm using one primary and two secondaries. Look at this, two secondaries individually operating as one half wave rectifier. Okay. Upper part of the rectifier circuit is one half wave rectifier, and even the lower part of the circuit is another half wave rectifier. It means full wave rectifier, if I consider full wave center tap rectifier, that full wave center tap rectifier handle two half wave rectifiers. That's what the actual thing is. Two half wave rectifiers are included in full wave center tap rectifier. And how this is possible? Because we have a center tap or transformer. Center tapping, one tap is common. Is it one tapping means taking out? Is it taking out and divide the things? I hope you understand what I want to say exactly. So basically what is that? It is a center tap type of transformer which divides a circuit into two half wave rectifiers. Is it? So now let's start with the operation. What is there at the output? At the output I have connected one resistor. I will call it as load resistor. And then in this circuit we have two diodes. The upper diode I will give the name it as D1 and the lower diode is connected. I am giving it name as D2. See, the cathode of both the diodes are connected to each other. Look at this, cathodes are connected to each other, but the anodes are connected to two different ends of a transformer, a center tap transformer. Is it? This middle one is common. It's not good to draw the ground signal as like, but as it's a common for our understanding, I am drawing a common or ground thing, zero terminal thing, zero potential thing. Is it? Now let's try to understand the operation of this rectifier with the traditional method. Is it same as when positive half cycle comes, what happen, and when negative half cycle come, what will happen? Is it like this way? Let's start with. So when positive half cycle of the input signal comes, look at this, a positive half cycle, then obviously this phase becomes positive. This phase is positive, it means this phase becomes negative. This phase becomes positive, this phase becomes negative. So as if this phase is positive, this diode will start conducting. This is in on state. We are assuming diodes are ideal. Ideal means what? Zero knee voltage. Is it? Now the diode is in on state. What about this diode? Diode D2. Diode D2 will go into off state because its anode is receiving negative voltage. As the diode D1 is in on state, current will start flowing in this direction. Look at the direction of current. Yes, and this is how it will complete the network. Current is flowing in downward. So because of that current which is flowing through load resistors, some voltage will get developed. Let me draw the output voltage waveform also. Now here, because of the current flowing, some voltage will get developed between the period of 0 to pi, that is during positive half cycle. This is what voltage available across the load resistor. Now during negative half cycle, what happened? I know that you people are already aware with the operation of this complete circuit, but still let's understand it once again. You consider it as a revision. Now during negative half cycle, what will happen? This phase becomes negative and this phase becomes positive. And now as if this is positive, this becomes negative and this becomes positive. Now look at this. The diode D1 is at the negative potential. It means the anode of diode D1 is at negative potential, whereas the diode D2, the anode of diode D2 is at positive potential. It means now during negative half cycle, this diode will go into on state and this diode, the diode D1, will go into off state. Look at this. During positive half cycle, diode D1 is in on state and diode D2 is in off state. During negative half cycle, what is the scene? The diode D1 is in off state, whereas diode D2 is in on state. This is how diode D1 and D2. Now during negative half cycle, diode D2 is in off state, is in on state. Then the current will flow. Let me take another color. Now current will start flowing in this direction. Look at this. Look at this thing. Look at the yellow thing. It is visible. Yellow is visible. Yes, yellow is visible. Or let me change the color. Let me undo the things. Okay, let me take which color? Okay, let me take black color. Okay, now diode D2 is in on state. So current will start flowing in this direction. Look at this. And again it will go through the load resistor and it will conclude sorry here somewhere. Now this is the direction of current. Look at this. In even negative half cycle, current is flowing in downward direction. Is it? It means the voltage will be developed again in the same direction. Let me draw the voltage developed. This is what voltage developed during pi to 2 pi. This is how output waveform we are getting from 0 to 2 pi. Look at this. The waveform repeats itself 2 times during the period of 0 to 2 pi. This is all about the operation. During positive half cycle, yes, I am getting output voltage in the same direction. During negative half cycle, yes, I am getting output voltage in the same direction. But the way to produce the output is different. Why? Because during positive half cycle, diode D1 conducts, whereas D2 not. In negative half cycle, D2 conducts, D1 not. This is how alternately during positive and negative half cycle, two diodes D1 and D2 will conduct alternately and produce output voltage, which is this. Is it? And this output voltage is not pure DC, because I know that pure DC form of or pure DC voltage looks like this. This is what pure DC, but this voltage which this rectifier has produced is not pure DC. Then what is that? It is a pulsating DC. We had discussion about pulsating DC in half wave rectifier. So as if this is also pulsating DC, then again in analysis we have to find how much DC current is there, how much DC voltage is there, how much AC current is there, or what is the form of AC voltage is there. Like this again we have to derive more than 12 or 13 parameters, and we have to analyze this full wave center type rectifier. Is it? So this is about the operation of full wave center type rectifier. In next lecture we will start with actual analysis of full wave rectifier, and let me tell you, the analysis of full wave rectifier will be same as the analysis of half wave rectifier. It means we will follow the same method that we followed in case of half wave rectifier. Is it? The methodology will be same completely, and that's why what I will do for your sake, I will take reference of half wave rectifier. It means whatever things I have written in half wave rectifier, we'll take those things in front of us and we will modify those equations itself. Is it? So whatever equations we have written for half wave rectifier, we will modify those equations while analyzing full wave rectifier. So what it will is, it will help us to save a time. Is it? We will save a time, and side by side you will understand that I am using same methodology to derive both the rectifier parameters. Is it? So in next lecture we will start with analysis of full wave center type rectifier. Okay, thank you.